This video is a refresh of an earlier video demonstrating the jpackage utility. To the uninformed, jpackage is a new utility available in JDK14, which enables you to create native install images of Java applications such that you can install them the way you're accustomed to installing, say, a Windows or a Linux or a Mac OS application. The reason for the refresh is the fact that the earlier demonstration did it on a prototype version of jpackage available only in a special one-off JDK13 build. It has since been integrated into a JDK14 as an incubator package, and the API has changed between those versions, thus warranting the rationale for creating another video. So the application that will be used is the same as the previous version. Basically, this socket client FX application, it's a JavaFX app that visually shows how you can connect up sockets and send and receive data. It's the client side of a connection. What you see to the right is something called multi-socket server FX. It has the ability to connect up to multiple socket client FXs at the same time, and we can send messages between them. But for the sake of this demonstration, again, we'll focus on the socket client FX. These other sort of iterations you can also download at my GitHub page if you want to take a look at them. So let's very quickly pull down and build the source, the socket client FX application. It is available at the following GitHub location. Further on down on this README, you'll see that there are related projects to the server end of the client connection, socket server FX and multi-socket server FX. But all you need to do here is just simply go to the Git string. We can copy it, open up something like a PowerShell, and just do a git clone on that string, and the source is pulled down. The project is in Maven format, so we can issue the simple Maven package command. Well, first we need to get into that directory, and then issue the Maven package directive to build the source. It's not a very complicated program, so it should be pretty quick. And upon doing so, if we just do a Maven exec Java, we can run the program. This socket client FX application is modularized. It uses the Java Platform Module System. We can confirm that by looking quickly at the source. Notice there is a module-info Java file. That's a pretty good giveaway. And if we look into the details of module-info, you'll see that we list the specific components required to run the Java application. So there are a few that are built into the Java runtime, the Java dot, so java.base, java.logging. There are some external modules required to run this. So JavaFX is no longer part of the standard JDK. It is actually external. So we'll pull these from the Maven repository. And finally, there's a com.jtconnors.socket library that we're also pulled from the Maven repository to do our socket type utilities. So, with that in mind now, let's go ahead and create a J-linked image containing only those modules required to run this socket client FX application. One of the aids we'll use in building the J-link and native images is we will enlist the services of a few scripts to make our lives a little bit easier. What you'll notice is in the project, there is both a PS1 directory or PowerShell. Those are scripts that run on the Windows platform, and an SH directory for the same type of capability on the Mac OS or Linux platform. We'll use these shell scripts to perform the tasks that we want. In there, we'll be able to print out the command line and explain what exactly is going on as we create these images. The aforementioned scripts share a common include file, which includes common command line arguments that they all can take advantage of. So that enables us to run any one of these script commands with the -? Option, which will tell you what your available options are. And in particular, what we want to take advantage of is the availability of a -E flag, which will effectively echo the invocation of the pertinent JDK command prior to actually doing the work specified. Again, these commands can get pretty hairy. This will enable us to examine what's going on as the image is being created. So let's go ahead and do that now with the first of our shell scripts called link, and we'll issue it with the -E option to give you a feel for what's going on here. So again, you can see how the command is pretty hairy, but in fact, it's not as bad as it seems. what you'll notice is the command starts off with the name of the executable, in this case JLink, which is part of the JDK. And really, the lion's share of the rest of the command line is this add modules. These are all the modules required to create this runtime image. This is specified, incidentally, in the module.info file. So you'll see references to all these particular modules in that path with their full path name. And then after you specify a module path, you need to issue this add modules directive and specify the name of the program and the module that you're going to use, which happens to be socket client FX, which is again defined in the module info file right here. Going on, we don't need to, but we added this additional option to make the runtime image a little bit smaller. And then what you need to also do is specify a launcher name. So when you start up this application, it'll be called socket client FX with the appropriate capital letters. And the way you designate what actually gets run under the covers is you need to specify a main module. That's the name of the program, main modules program, socket client FX, all lowercase, / and then the main class associated with that. And it happens to be com.jtconnors.socketclientfx.socketclientfx. And then finally, we need to tell where we want to output this reduced image in, and it'll go into the image directory. Now that we've created our runtime image, let's compare and contrast it to what a standard Java runtime looks like. So first off, we can go into the image directory and actually look at its version of Java. So we can just do a simple image bin Java -version, and it should look no different than your standard Java runtime, except for the fact that if we elaborate a little further and take a look at the modules available here via the list modules command, you'll see that it only contains the dozen or so modules required to run this application and nothing more. Whereas if we compare this to a standard Java runtime, you can see that there are many, many, many more applications. When we built this application, we also included a launcher, the socket client FX program. So we can just simply issue that here and run the command. And our program should start up wonderfully within this self-contained image. Finally, just to give you a feel for how these differ in size, if we open up a file manager and take a look at the image directory, it is about 53 megabytes, okay? Whereas if we compare a standard Java runtime, the runtime that built this, so if we go to the Oracle JDK14 directory, it is in the neighborhood of 300 megabytes. So obviously a lot smaller. It's a good way to sort of limit what you can distribute, save space, a little bit more secure. Lots of good reasons why this is a good idea. Let's move on to creating one of the native Windows installer options available. In this case, we'll create an exe file, and we'll take advantage of another script that's available in the PS1 directory called create exe installer. It will issue it again with the -e command line option to get a feel for what this looks like. Again, not as complicated as it may seem, because a good part of this is, once again, our friend, the module path. But over and above that, let's take a look at some of the other arguments. First off, the command itself is called jpackage. It's built into the JDK. It's available both for Windows, Linux, and Mac OS. We need to name the exe. It'll be called socketclientfx.exe. We need to specify the type. There are two options here. One is exe, the other is MSI on the Windows platform. And then obviously there are other types for the Windows and Mac OS platforms. We can specify whether or not we want to include a Windows shortcut when we install it. We've already talked about the module path. Further on down, we need to, as in the past, kind of specialize or specify how this thing will really start up on the inside. And the way you do that is you need to name the main module, which is socket client FX again, / and then the main class. That's pretty much all that is required to do this. And now, once we're finished, a socketclientfx.exe file should be available in our directory. It is in the temp socketclientfx directory, and here it is. And I can double click on this now and install this. So let's go ahead and do that. And ultimately what should happen is once this is installed, it'll be placed into the registry. Need to type in a password first. And it is done. Now, what you'll notice is we have a Socket Client FX icon created over to the left here. I can click on that and go ahead and start the application the way you would a normal Windows application. And furthermore, we can show that it's installed kind of in the registry by taking a look at the control panel and getting over to the Programs and Features section. And you'll see that Socket Client FX is in fact available right there. Let's not neglect our other supported platforms by moving over via VNC to our Ubuntu desktop and show how we can create Linux native images. In this case, we have already downloaded the Maven project. We'll move to the CD directory, the SH directory, and issue a create script, which will enable us to create a Debian installer pertinent for a canonical Ubuntu desktop. Again, issuing with the E command. This command line option should not look much different than the one we did on Windows. There is this massive module path, among other things. But really, what the only difference is, we specify a different type here. The options on the Linux platform are DEB or RPM. DEB works well in the Debian environment, of which canonical Ubuntu is a derivative. RPM is more towards the Red Hat, Red Hat Enterprise Linux derivatives, and Oracle Linux for that matter. So our Debian package is now created, and we can issue an install command appropriate for this platform. And now the Socket Client application is installed, and by default it goes into the opt directory. So we can run the command by just going opt socket client fx bin Socket Client FX, and now our application should start up just the way typical, native application in Linux runs. Final task, we'll move over to a Mac platform. We're going to VNC into that machine now, and we'll demonstrate how we can create native installers not only on the Linux and the Windows platform, but the Mac platform too. So I've taken the liberty of already downloading and building the Socket Client FX application. In this case, we'll just issue another one of these create scripts. This one is called create pkg install.exe. There's also a DMG installer that's available for the Mac too. So this command should not be all too different than what we've done in the past. Again, we have this huge module path. And really the only difference is this time we specify jpackage with a type pkg. The other option available in the Mac world would be type DMG. But again, we've chosen PKG in this standpoint. This task has completed already. So if we go to the Socket Client FX project directory, you'll see now that there is a PKG file. We'll go ahead and double click on that to install. And we'll go through the steps in order to do that. Somewhere along the line is probably going to ask for a password, sure enough. And now installation should be complete. We can confirm that in fact installation is there by going to our applications folder within the Finder application, and you'll see that there is a Socket Client FX application installed. So I double click on that, and sure enough, our application starts up the way you would normally expect it to, including a little Dancing Duke logo in the bar. So hoping this was instructional. Thanks for your time.